Hi everybody, welcome to the Manifold channel. We're going to take a look at how to work with WMS and Manifold today using the WMS capabilities of Manifold Server. We're looking at the Manifold web page here, and what I'm going to do is I'm going to pull over a table from a Manifold project that's in a different window, and we're going to take a look at the websites that we're working with. When Server creates a website, Server automatically generates a WMS serving capability for that website as well. So we're going to work with the Eclipse's website, the Eclipse Terrain website, and the Mexico website that's hosted on our local machine. So let's right-click on this. This is, of course, a Manifold table with the various URL strings saved and styled. Let's click that Style button as URL so that when we right-click on them, and it'll launch in the browser. So I'll click Open URL, and that'll launch the Eclipse's website. The website has a lot of layers here. It shows total eclipses of the sun, and if we want, we can zoom in to, say, the Egypt location, and using the information tool, if we click on any part of the eclipse path here, it gives us the time for when the eclipse path, the UTC time when the total eclipse starts, the duration of the eclipse in seconds, and the date. And if we click on where there two eclipse paths overlap, it gives us the uppermost one. For example, the eclipse of 2034. Here, where there's only one eclipse path, it gives us the total eclipse of the sun in 2027. And if we click somewhere else where there isn't an eclipse path, there isn't any data there because all those layers have been turned off or they're not pickable. Okay, so far so good. And let's go back to zoom to fit, and we'll zoom into here. Let's see, we'll zoom to here in the Balkans. Variety of ways to zoom. And you notice as we zoom in, different layers turn on and off. So, for example, the roads layer turns on as we zoom far enough into the Balkans. The blue background here, where there is water, is created by a background layer in the map in this particular project. So let's remember that. Okay, that's the total eclipses. And if we want, there's a variation of the total eclipses one, which website which has the terrain in it, because we can turn on and off terrain here. Let's zoom back to Egypt, and you can see here we can turn on layers like the terrain layer and the country borders layer, and that gives that sort of effect. Now let's say we wanted a website that had the terrain turned on by default. We can do that, and in fact there is a website like that that's available on the demo server, and that's this one right here with an A appended to the URL. And let's click Open URL, and that launches the website there. So you can see that if we zoom to fit to, well, let's zoom to fit, say, North America, you can see that it has a terrain layer. And let's zoom to Egypt, and you can see that has the terrain turned on by default. If we can turn that off and we get back to the countries, oops, we don't have a countries layer in the terrain version of it. We just have the terrain layer. So there we go. Okay, there's that. And there's one more website that we're going to be working with here, which is a website that I created on the local machine. And click Open URL. This is just the local host website, and you can see it just shows the states of Mexico. So that's a very simple deal. And if I click on the information tool and click on any of these spots where there's a state, we can get the data for that state. And there's only a few fields here. There's population, automobiles, and the name of the state of Mexico. Great. So those are the sites that we're going to be working with. And now let's learn how to work with WMS. There's a variety of ways of working with WMS. And let's get a Manifold project up. Here's a Manifold project where I have a map that's already open. It has a Google Maps background layer. And I'm just using that for reference. It's a satellite layer. And let's create a WMS server. And what I'm going to do is I'm going to create a WMS server using the WMS URL for the Eclipse's website. And off screen here, well, actually let's do it on screen here. I'm just going to right click on this and choose copy, so I don't have to keyboard all this stuff over and over. You can see, hey, look, man, no hands, no keyboarding. And then I'm going to create a new data source, and that data source is a WMS site. So we'll call this oops, let's type this out, Eclipses. And the source is going to be right here. And I'm going to turn off cache data because I want this razor sharp. You can read about that in the user manual if you like. And let's test that. When I click test, yes, the connection is established. Click OK. And so now when I click create data source, there it's going to create that Eclipses website. There we go, total eclipses. And if I drag and drop this map image into the display here, there's two things that you can see. Let's zoom to fit on the Eclipse's website. You can see that where the blue background used to be in the website that was generated for the web UI, there's no blue background. It just has a transparency in between the countries layers, and that's so you can let's go back to the previous view. That's so you can compose the transparent ping that's being generated for these for the WMS displays with other sites. For example, here you can see how in the transparent regions between countries the Google Maps satellite layer is shining through. And there also has partial transparencies. For example, where there's partial transparencies, for example, in the Eclipse paths, you can see the bathymetry in the Google Maps satellite layer through that partial transparency. So that allows you to do a whole lot of cool effects, and that's why that's done. We can also, if you like, let's create one for the. I'm going to copy the URL here for the terrain. Right-click, copy, super, and then here let's create another data source. Well, I'll do it up here so you can see the whole menu stack. Click more, and here let's call this Eclipse's terrain. Click that and create data. Oops, I don't want to do that. I want to uncache that. Let's do that again. Click new data source, more, and we'll call that Eclipse's terrain, and the source is going to be that's going to be the URL for the terrain layer. Notice there's the A afterwards, and the way we form, by the way, a WMS URL for any website that's created by Manifold is just automatically just add /WMS, and that's the WMS server for that website. Click create data source, and now if I pop this open, you can see there's that the terrain-based image here. Now, why does the terrain-based image have all this blue color in between the various countries? That's because the terrain image has a big terrain layer that's a 17 gigabyte raster layer, and the 17 gigabyte raster layer doesn't have objects in it. It doesn't have any drawing. It doesn't have any areas for the countries. It just has one giant raster that's 17 gigabytes that shows all this in high resolution, and the raster includes blue color for the background. So if we drop the Eclipse's terrain layer into this map, you can see it's going to cover up everything that's behind it because it's just one solid raster. Turn that off, and we can see what the version looks like, which uses a vector layers only, which shows nothing in between the various vector objects, so the terrain shows through. Okay, all that is super cool. And notice, by the way, as we zoom further in here, more and more, the WMS server automatically understands all the logic that's been built into the project in terms of when new layers turn on and off. So as you zoom farther in, for example, it turns on roads layers and other sorts of things. Okay, well that's great. Now, how do we actually use WMS in using a request, WMS requests? Those are all URL requests, and here's a bunch of the URL requests. For example, if you want to see what the WMS server is capable of doing, we can copy this and right here, that string, and paste it into the browser. Or what I'm going to do is I'm just going to right-click on it to launch it, so I don't have to keyboard anything or copy and paste it. So if I open the URL here in the browser window, here we can see the request, and the way it starts is with a question mark, and it says the service that we want to use, which is WMS. It says the version, which is always 1.3.0 for current versions of Manifold Server. And it issues the request, which is a GetCapabilities request. The GetCapabilities request simply reports an XML text file that says, what's going on with that particular data source. For example, we can see that it's capable of generating images that are up to 4096 by 4096 pixels in size. It shows that the GetFeatureInfo request replies in application/JSON format, and it shows that the image is in EPSG 3857, which is a Pseudo-Mercator, and it shows the minimum x, minimum y, the bounding box in min x, min y, max x, and max y in Pseudo-Mercator coordinates, which are, of course, in what do you call them? Meters. There we go. So what can we do with this? Well, we can use this information in various strings like this string right here, the URL string, to use the GetMap request. And what the GetMap request does is if we go in here, you can see it takes a bounding box in those coordinates, and it says the height and width of the resulting image that we want to generate and the format that we want that image to be in. And in this case, it's always going to be ping, image ping. So I'm going to right click on that, choose open URL, and that's going to open up that URL in the browser. And what that URL does is that generates it's a GetMap request, which uses a bounding box of these values with a width of 800 and a height of 600. And the result is an image that's 800 pixels wide by 600 pixels high, which encloses the bounding box of these coordinates in the Pseudo-Mercator display. And I'll mention later how we got those coordinates, how we can get them. That's easy enough to do. If we like, we can change those coordinates. For example, we can do here, which has similar coordinates, but they're bigger. For example, the minimum x and minimum y are much larger. And let's launch that. And what you'll see is that generates a GetMap image, which is larger. Here's the Balkans that we originally looked at, but when we make it a lot bigger, we get considerably more. Now, the browser is filling in the transparency here with this beige background. That's not in the map because the map uses transparency. If we actually save this ping image, here right-click on and save as image, and then open that image in Photoshop or some other graphics editor, you'd see that the ping image has transparent pixels in all these regions in between countries. So comparing that to here, you can see how the specifying a larger bounding box gets you more of an image. The other thing is that when you specify a larger bounding box, the display has to be zoomed out farther. And when it zooms out farther, then the logic kicks in, which turns on and off various elements. So for example, as you zoom farther in this particular project, the roads appear. When you zoom farther out, the roads aren't there, and there are fewer populated place names as well. So all that happens automatically. The WMS's image that's generated is literally what you see is what you get, rendering of what you would get from the project by zooming in and out of the project. Let's see. We can also vary it to use a slightly different URL instead of the IMS9, as you see here. We can use IMS9A. So let's do that. Let's open URL, and here's the turn off the Africa bit. Here's the same bounding box that showed a region in the Balkans, but it's now with the server that uses countries. And here's the version of it with the server that uses the IMS9A version, which uses terrain. So you can get a lot of custom effects by publishing slightly different maps. Now let's go look at what we're going to work with right now. And here's the a bounding box that features Egypt. It's approximately where the Egypt location is in the website. So let's click Open URL. And that's a GetMap, which gets generates a view of the server with Egypt. And you can see that here's where the eclipse path overlays. And that, again, is corresponding to what we did earlier when we zoomed in with the location in the main website. Now, why am I showing you this? Because this image is what we're going to use to use the GetFeatureInfo. And what GetFeatureInfo is, it's a request format. Instead of request, GetMap, like here, you can see request is GetFeatureInfo. And what it does is it tells the WMS servers to pretend that it's generated an image of 800 pixels width and 600 pixels high that encompasses this bounding box, that encloses this bounding box. And within that, image, go to the horizontal and vertical location denoted by I = 400 and J = 300, and get the data for whatever object happens to be under there. And when you look at an image that's 800 pixels wide and 600 pixels high, the location that is 400 pixels from the left-hand side of the image, that's 400 pixels this way, and 300 pixels down from the upper margin of the image, is right in the middle of the image, which is right about in here somewhere. So that's getting the information for one of these eclipse path segments. Now, what happens if we launch that particular URL? I'm going to click Open URL on that, see what happens. And what we get is the attributes for whatever feature lays under, that is, feature is Esri slang for object. that lays under that particular spot. And in this case, that is the eclipse segment, which where the total eclipse of the sun starts at 9:58 UTC time with a duration of 383 seconds, which is an amazingly long time of totality, and on the date of Monday, 2nd of August 2027. And that's how feature requests are used. Now, why would people do feature requests like that? It's because they're using images like this in a website, where somebody's created a web application that pulls out from the WMS server specific images of with specific bounding boxes, and then typically such websites allow people to use some sort of info tool to click at a spot that they're interested in. And because it's a whole lot easier when you're developing a website to tell where the person has clicked by the number of pixels from the margins where the click occurs, that's why GetInfo, the GetFeatureInfo request uses this pixel coordinates of certain number of pixels from the left margin, certain number of pixels down from the upper margin. And what happens is that people write these websites which allow users to click on that spot based on where they clicked. They send out a GetFeature request to the server. The server replies with JSON data. And why JSON data? Because JSON is easily consumed. If you're writing a website, it's really easy to extract from this neatly structured form of data that is returned these fields like this, so that you can then format them to pop them open in some pretty box. Or if you like, if something here is a URL, you can use that URL to launch a new window in the website that's a pop open, or maybe an illustration of what's there at that location, or all that sort of jazz. So there you go. Now suppose you don't want to mess around with all this Pseudo-Mercator coordinate stuff, but you really want to do latitude, longitude things. Well, for that we can do something like working with the Mexico website. So the GetCapabilities for the Mexico website, and I'm going to close some of these things. I'm going to close this one, this one, this one, this one, and that one. And let's go back here to this table, and let's launch GetMap for Mexico. Well, let's first do the GetCapabilities. So let's launch that, open that URL. And you can see here in the GetCapabilities that this uses EPSG 4326, which is latitude and longitude, which means that the coordinates in this map are, well, latitude and longitude coordinates. So those are degrees. So you can use decimal degrees as coordinates, which is extremely convenient, to understand what's going on. So, for example, here's a GetMap request that uses these coordinates right here. You can see which are latitude and longitude coordinates, and let's open that URL. And there it generates. That's a zoomed in portion of central Mexico. And if we want to know, what are the attributes for this object that's right, for the spot that's right there in the middle, for this, which will be, of course, this particular state, we can right-click on this, which is a GetFeatureInfo request. And there you go. If you want, you can manually type all this stuff in, but I find it a lot easier just to save the strings that I'm using in a manifold table, and then right-click on them to open up the URL. And what we've done here is within this imaginary bounding box that's 800 pixels high, 600 pixels wide, at the location in the middle, which is 400 pixels from the left margin, 300 pixels down from the upper margin. You can use whatever number you want, but I find that easier just for the demonstration purposes to pick something in the middle. We get the information for the particular feature that is object, which is under that spot. That happens to be the state of Zacatecas. I hope I'm pronouncing that right. And these are the fields that are associated with the manifold ID, the population, and the number of automobiles in that particular state. So that's all there is to this. It's really easy to use all this stuff. It's easy to, as we've seen, it's easy to use these various layers as WMS servers inside projects, where we created this with the Eclipses layer, and created the Eclipses terrain version of it as well. And a lot of people, by the way, have standard base maps that they've created, which they'll use in their organizations, and they're just served from servers that are accessible on their local area network. And you can use those even if you want for projects that are later republished to the web, because what's in a project is in a project. Pretty much doesn't matter where it comes from. And it's just like if you're pulling something from Bing or some other OpenStreetMap or some other server, off you go. This data, by the way, that's and using all these comes from Natural Earth. So, if anybody has any beefs with, what Natural Earth showed in terms of outlines for Switzerland or Austria or Montenegro or any of those other places, that's a Natural Earth thing. That's we're just using it as a matter of convenience, nothing political intended. I did promise I would say how to, if you wanted to get the bounding boxes for this, how to do that. That's easy to do. We're going to create a drawing here. See, new drawing, and it's in Pseudo-Mercator. Cool. So great. I'm going to drag and drop that drawing into the map. And now let's say I want to find out what the bounding box is right about here. What I'll do is I'll create an area. Click, 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 and then I'll add record, and there's my area. And what I can do is, if I like, is I can let's go back to the default cursor, and I'll click that to select that area. Actually, let's style this so that the area has transparent innards. Super. Now back in the info pane here, I've all picked this, and now in coordinates I can see what the coordinates are here. And you can round these coordinates off if you like. So for example, let's change this to 673. That's 167. That's what, 4 zeros. 1, 2, 3, 4. Yeah, great. So that's about right. So what I can do is I can copy this. So that's this. Copy this and then paste it wherever similar coordinates are like. That's how you round off a square. And I can do the same here. And then if you want, just read off the minimum and maximum coordinates here. For example, the minimum, let's see, that would be longitude would be this, and the maximum would be that. And the minimum latitude would be this, and the maximum would be one of those. And that's where you get the bounding box coordinates if you want for in Pseudo-Mercator coordinates. If this was a latitude and longitude map, these would be in latitude and longitude degrees. So that's just really easy to do, and you can do it whenever you want. Okay, I hope you've enjoyed this quick video. This shows you how you can work with WMS and do all sorts of cool things with WMS. It's deleted from the map. And turn things off and on, and either use WMS servers in your maps, or if you like, learn how to work with WMS in terms of services to get capabilities, to do a GetMap, and to use GetFeatureInfo requests to get data for objects that are located in a particular spot in a particular image that's been generated. Thanks for watching. I hope you've enjoyed this video. If you have, tell your friends all about Manifold, and goodbye from Manifold Land. Well, that was fun. If you want to see more, visit us at www.manifold.net. As always, Manifold delivers the world's most advanced, highest quality spatial products for GIS and DBMS at a low price that you can afford. Once again, that's manifold.net. See you soon.